just confirm that we are. Oops. Switch. Let's see. Broadcasting. Stream manager. Okay, there I am. But sorry for this boring part. I will obviously timestamp when I actually get into things. Why are you showing me live? I don't want to see me live. I want to see what's this on. Just scroll down. Let's rename this baby. OpenCV Part 2. Alright, done. Stream info updated successfully. Cool. And let's get one here. I'll close some tabs. And we'll open other ones. Back my stream. Okay, I'm just playing the wrong thing. Okay, apparently I did not open up the correct code file. I was working on something else yesterday. So let me just open that up. It is called GTK. Okay. Oh, there we go. We already have it open. Let's just switch to. Okay, cool. Sorry for that. Wait. Now let's get into it. Does it look on stream? Okay, perfect. I really should get a second monitor to so I can just keep an eye on what it looks like for everyone. But anyway. Alright, so we stopped here last time. The Gtk Startup. So let's go to the main. We got a source, we got a CPP, we got a main window. That's the one they're talking about. Right? Main window, include it there. Where's their main? Window, main window, 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 window. Well, that makes a lot more sense. So, I mean, anyone familiar with C++ would really know what's going on here. Importing the H file. We have our main function. We're declaring an app object, instance of an app object from the GTK library to create a function. It's the arguments Who knows what this is? I think this is a pick whatever you want string because they have it different here. We should probably like look up what that is. Right? And if they don't mention it, we'll look it up. Then we make a main window object, and we tell our app to run the main window object. Cool. All right, let's read what they wrote. The Gtk Startup, all C++ executables need a main method as the entry point. To launch a GTK application, you need to specify a main window, which will act as the base for all other user interaction, including to open more windows. So you gotta have a base window. That's rule number 1. This is the main function. We'll just kind of walk through that a little bit. Loving this auto type. Very definitely a good thing. Declaring a variable as auto, well, here we go, specifies that the type of the variable that is being declared will be automatically deduced from its initializer. This is called type inference. Okay. The call the GTK application create initializes a new GTK execution context, passes the program arguments, argc and argv, and sets the application ID. That can be anything, but convention says that it should contain your domain name in reverse, followed by its name. CH-AGL development, CPP tutorial - Raspberry Pi, CPP GTK OPENCV. Once you have a context ready, you can use it to open a window. That window can be an instance of any class that extends GTK window. Cool. In this case, our main window is called quite explicitly main window, and it is an instance of a class main window that we will define later. The way we define, it's the difference between define and declare. The main window variable makes it an automatic variable. This is not the same as an auto type inference modifier seen before. Automatic variables are initialized and allocated in memory at the point of definition, and uninitialized and deallocated automatically when their scope is ended. Read more about scope there. On a local variable, this happens at the closing of the curly brace of their code block. We don't need to care about deleting automatic variables. See, in contrast, dynamic memory allocation with new and delete, and also dynamic memory allocation here and increase for weeks. Whenever the type of variable is a class, as opposed to a basic type like int, the class constructor is called with the construction arguments and returns the initialized instance. In this case, construction arguments are the initial size of the window. Okay. Oh, yeah, they're just kind of, this is a cool section, and I like how thorough they are for this tutorial. They like really go into what is a class. Of course, we don't know what class is, right? Anyway, just for tutorial completeness sake, gotta walk through it. The call to run will return when the user closes the window. This gives the GTK execution context the opportunity to control the exit status. Okay, great. So we call it the basic GTK window. In GTK, all buttons, labels, checkboxes, and elements that displays or interacts with the user is called widget. Here is a gallery of widgets. Let's actually sidetrack that. So pick up, yeah, cool. do we have the list of widgets? Then GTK adds its own sauce. GTK arranges widgets as hierarchically using containers. A container widget contains other widgets. Most GTK widgets are containers. Windows, notebook tabs, and buttons are all container widgets. There are two flavors of containers: single child containers, which are all descendants of GTK bin, and multiple child containers, which are descendants of GTK container. Most widgets in GTK are descendants of GTK bin, including GTK window. Check out the official documentation if you want to. Main window class declaration, the header. Okay, main window. Let's go to window. Let's go to header. Right. Where did this have to go to? Main window class declaration. The header. Okay, so this conditional if. Got some includes, local files, also system library that we installed. We declare a class, main window. Sure, this is inherits from the GTK window, like it said. You have a public, you have a constructor, you have a virtual destructor, you have a protected method. It's an event, and we're overriding it. Cool, so I guess it's a method we're overriding. GTK window or something. Then there's some prior ones. Button click, probably in full screen. And button, and box, and label, and camera drawing area. That's it. And let's continue this tutorial. The class main window published GTK window declares main window as a class and is as descendant of or inheriting from GTK window. The public modifier makes all public members of the ancestor to be also public members of the descendant. Public inheritance is the most usual way of extending a class, in contrast to private inheritance. We're providing main window to the GTK execution context, which is expecting all functionalities of a GTK window to be available so we avoid restricting their access. As a descendant of GTK window, main window is a single child container that can only contain one GTK widget. It chooses to be a box, which is a container, so in turn it is able to contain several widgets. In this occasion, I want them to be one GTK button and two GTK labels to illustrate the packing mechanism that GTK uses to stack together a bunch of controls. For main window to respond to clicks on the button, we declare a button click method. Could be any name. We don't just name it anything. We're very aware in this tutorial. I'm explaining later how we connect to the click to signal it. Okay. Blah blah, we went over this. It's a box it is, we got a button, we got a labels. We know the plan. I will be right back. All right, well, I didn't realize I didn't have my mic clipped to me, so my audio was really bad this whole time. Sorry. I mean, at least we're getting to the code now, and the rest was pretty much expository, so if the audio doesn't come out great, then it's not that big a deal. We didn't miss much. Anyway, let's get back to it. The first two methods are the constructor and destructor. As said before, constructor is called every time we declare a new instance of this class. The constructor accepts initial width and height of the window as parameters. Whenever an instance is destroyed, the class destructor is called to perform all needed cleanup tasks. The destructor also has two important modifiers. Virtual. That means, in case of inheritance, the method called will be that of the dynamic type. Read more about what is dynamic type of object, virtual functions, and why most of the time it is a good idea to have virtual destructors. I believe it. And default means that we define this destructor to have a default implementation. The default implementation of a destructor is able to deallocate all the defined members of the class, which are and box and button and label. Code button click is a method, therefore it doesn't need to be allocated or deallocated. Okay. By specifying the default implementation, we spare ourselves the need to define the destructor. That is sick. You just do virtual destructor default? Wow. I don't remember when you had to write destructors. I mean, yeah, that's really all you wanted to do is just like deallocate the memory, bro. It doesn't need to be that serious. I guess they finally came to the terms with that. Of course, they go on to say the memory model of C++ has no garbage collector. I mean, you just said here's how you could do a garbage collector, but you know, to each their own, I guess. Let me scroll up. Yeah, this model of C++ has no garbage collector. Reserving and freeing memory reserving and freeing memory relies on the presence of class constructors and destructors, and on a strategy called resource acquisition is initialization. That, okay, yeah, that's like the thing to know in C++ is RAII, resource acquisition is initialization. I thought it was instantiation, but whatever. That's huge. I don't know. It's important. This is essentially saying like when you make an object, that's like, yeah, resource acquisition is initialization. Anyway, let's look at the source for this main window. We were in the HPP, now we will go to the CPP, C++. Let's see. We can put our H file. We have syslog. We make our, is this weird? What is this colon? What is going on here? Commas. What is going on here? I guess they'll talk about it. All right. Anyway, set the default size. Connect the click signal and make the button visible. So signal clicked, connect. Okay, so set up your signal handler and show it. Make the first label visible, make the second label visible. Pack them all in the box. pack is like, okay, flexbox. Add the box to the window, make the box visible. Okay, I think we've all seen stuff like this. This is like when Java, how you do Java callbacks, and this CSS inline. I forget, I think they call it Spring. You can make it a web app and you get the callbacks, and it's really not too funky, but it's all in Java. Excuse me. Anyway, and then look, you have the function button click that you set up here. You're going to call when you get clicked. And since syslogs this, and I added this printf yo on key press event. Well, event is key val, so there's a little switch case to detect different key presses. And it's pretty straightforward. They got the nice aliasing to, you know, you just say big C or little c, you don't need to look up numbers. Anyway, that's the meat and potatoes of this CPP file. Let's see what they have to say about it. Declaration of the main window requires two further definitions, the class constructor and the button click method. Here is the code, which we just went over. Hello, can I scroll? What happened? Okay, here we go. The full name of the constructor is main window, meaning it is the function called main window. The name of the constructor is the same as the class. That belongs to the class main window. It takes its width and height as parameters and starts by calling the constructors of all declared members. Read more about constructor member initializer lists. Then we set the window's default size by calling this set default size. This is a pointer to the current class instance. This, yes, that's what this is. This is like self in Python, for the most part. Anyway, this is a pointer to the current class instance. As it is a pointer, we use the arrow to access its members. As class main window extends GTK window, this instance contains all public or protected members of this class and those of the parent class. This is called inheritance. The use of this pointer is actually optional, and the following snippet is also valid. Configure this window now without the this. You just do set default size. They know what you mean. Come on, did my scrolling break? Anyway. Next, we want to react to the M button being clicked. One way to achieve this is to connect a function to the click signal of the M button instance. To see all available signals of a widget, you can check the official documentation. For example, the GTK button only has the clicked signal. Connecting functions to widgets signals allows to process the event from anywhere in the code as long as you have access to the widget and you can provide the address of the function. Yeah. You take the button, you get a handler, connect to the method. Great. The address of the function can be as simple as placing the function's name. See about the address of a function. Our case is more complex because the function we want to display is a member of a class. Member. Member functions need to be provided with this pointer so it can access other members of the same instance. To build the pointer to a method, of a specific instance, we use sigc mem fun to build a pointer to a method of a specific instance. Member functions need to be provided with the this pointer so it can access other members of the same instance to build the... Okay, and that's why we installed memc, or sigc, sorry. By default, widgets are not visible. We need to set their visibility explicitly by calling show. Blammo, right there, and right there. Next, we pack all elements in the box. During initialization, we already set the box to GTK orientation vertical, which means the widgets will be positioned one below the other using all available horizontal space. Pack start adds a new widget to the box. GTK pack strength specifies that the widget's vertical size should be as small as possible. Orientation vertical already specifies that all widgets in the box should have a width as big as possible, so the result will be widgets with very wide, that'll be very wide and very flat. I'm typing over here. In contrast, GTK pack expand widget specifies that the widget should take all available space. This makes the M label to expand when the user expands the window. You can test this shortly. The last step is to make the M box itself visible. Did we do that? Yeah, down here. After we add all the stuff. Oh no! Where'd it go? Let's see. Blah, 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 blah. sigc. Okay. The last step is to make the M box itself visible. As for the button click method, we just display a message to the standard output. Skip this section because we're not launching in Xcode. We're launching in Linux. Oh. Log into this log. Okay, so they get into more specifics here. Display camera. We'll launch it next time. We got a nice little run through on how GTK works, but I have the whole app in here done, and I don't want to spoil it with running it just to demonstrate GTK to you. But we can play around with it afterwards, you know. Once we see the full thing, we'll tear it apart piece by piece and go backwards. I think that's something reasonable to do. Anyway, thanks for coming to stream with me. I hope you enjoyed it, and see you next time. We will be launching the application.